Okay, hi everyone. We'll be looking at the second part of mole ratio. So this is where you have put in what you have learned in the first part, the four formulas, into a setting of a chemical equation. Okay, and we shall see this thing called the mole ratio and what does it mean by mole ratio. Okay, so just as a recap, okay, of the very first part, so basically everything you can link back to mole. Okay, you have mass divide by mr, you can get mole, and then for mole you multiply by molar mass mr, you actually get mass. Okay, but mr actually means relative molecular mass. In actual fact, this formula should be multiplied by molar mass instead, but the number is the same, so I get lazy sometime and I use mr. Yeah, okay, so concentration, okay, in mole per dm cube. To get to mole, you must multiply by volume in dm cube. Okay, the other way around, you divide it by the volume in dm cube. Okay, so next thing, you have concentration in gram per dm cube. What you can do is you divide by volume, then the other way around you multiply by volume in dm cube. Yep. Okay, so of course you can interconvert between these two units of concentration. From gram per dm cube to mole per dm cube is pretty much like a mass to mole conversion. So you divide it by mr. So mole per dm cube to gram per dm cube, you multiply by mr. Okay, so you already have this on the second page. So this is just a recap. Okay, then you also have another one for the number of particles, which is seldom used in the second part of mole actually. Yeah, then this is divided by 6 times 10 to the power 23, the Avogadro's constant. Okay, and the last one is the volume of gas, only for gas, because the last thing I want you to do is take the volume of a solution and apply this formula. Okay, so mole you divided by you multiply by 24 dm cube, you get volume of gas, or 24,000 depending on what does the question want. Okay, volume of gas you can divide it by 24 dm cube or 24,000 centimeter cube depending on what the question want. Right, so this is a quick recap. In a nutshell, this is what we covered in the very first part of mole. Okay, so now let's continue okay, to calculations from chemical equation. So you probably have done balancing equation, okay, when you are in N levels. Okay, so if you notice okay, what we are doing down here is actually stoichiometry. It's the relationship between the number of moles of reactants and the number of moles of product in a chemical reaction. Okay, so let's take a look at this. This is sodium hydroxide with sulfuric acid. Okay, just in case you forget what is NaOH. Sodium hydroxide and sulfuric acid. Okay, so what you have is okay, so how do I get this mole ratio is this. You look at the big numbers, the coefficients of the equations. Right, okay, so the mole ratio will be 2:1:1:2. Okay, so that's to help you understand what does mole ratio mean. Basically it's the big numbers okay, the coefficients of the equations. Okay, so let's take a look an example on that we make use of this mole ratio. Okay, all right, so you are given this reaction. You're asked to find the mass, okay, of your sodium carbonate. Okay, and then you are given 16.8 grams of sodium hydrogen carbonate, which is this value. okay, is heated strongly until there is no further change. Okay, so this is a chemical equation, so you must find the mass. So what you need to do is this, it's like a three-step scenario. Step number one, you must change this to molar, 16.8 gram, okay, by dividing by mR, right? Okay, this chapter is called mole concept for a reason, because a lot of things link back to mole. Then after that, you use the mole ratio, which is 2:1, right? So you 2 units to 1 unit divided by 2 to get the number of mole of the sodium carbonate. Then after that, you multiply by the mR of sodium carbonate. So we are looking at a three-step scenario. Okay, so first thing first is to find the number of mole of the sodium hydrogen carbonate, okay, by taking mass over mR. Okay, mR you have to check out the periodic table lah. Alright, so this is 16.8 grams, sodium is 23, hydrogen is 1, carbon is 12, and plus 3 times 16. Okay, so that will give us 0.2 mole. Right. Okay, so next thing is this. Okay, the ratio of your sodium hydrogen carbonate to sodium carbonate is 2:1. So what you can do next is you can find the number of mole of sodium carbonate, okay, by taking 0.2 divided by 2, so that's 0.1 mole. And then lastly, you will be able to get the mass of your sodium carbonate by multiplying by the molar mass. Okay, so now you have reached, you have done this, you have done this. So next thing, I can get the mass of my sodium carbonate by taking the mole multiplied by the molar mass. Mole is 0.1, molar mass. Okay, so you got to check the periodic table for the relative atomic mass. (106), so 0.1 times 106, so that gives you 10.6 grams. Right. Okay, so in actual case, of course, I won't break down into steps like this for you lah. Alright, but this one for the start is to guide you along. Okay, alright, okay, let's look at more examples lah. Alright, for this particular part. Okay, next one, example 11. So you are told, this one you probably have seen before lah, from the blast furnace, this reaction. So iron is obtained from iron ore which contains iron trioxide. So a reaction of iron trioxide with carbon monoxide to produce iron is shown in the equation below. Okay, so you are told to find the mass of iron, which is this fella, and you are given 63. Okay, just a second. Okay, you are given 63 dm cube of your carbon monoxide. Okay, what is the mass of iron produced when 63 dm cube of carbon monoxide reacts completely with the iron trioxide at room temperature and pressure? Okay, so what you can do first is that you can find the number of mole of the carbon monoxide, but because it's a gas, so you can apply this formula, right? Mole 24 volume. Okay, so this one is divided by 24. Then after that, mole ratio over to iron, okay, which in this case, is 3:2 the ratio. Okay, then after that, mole you can multiply by mR to get mass. Alright, as can be seen from this formula. Okay, so let's take a look at this. Okay, so step number 1, I will be finding the number of mole of my carbon monoxide. Okay, I will write down a formula first. Okay, by taking volume over 24. Okay, so volume is 63 divided by 24. So 2.625. Okay, next thing you have 3CO is to 2Fe. So the number of mole of Fe will be 2.625 multiplied by 2/3. Okay, so from 3 units you want to find 2 units, so multiply by 2/3. Alright, let me check the answers. Okay, so this is 1.75 moles, right? Okay, so then the next thing that you want to find is, okay, so now you got this. The last thing to do, you can find the mass of the Fe. Okay, so writing of the statements is important. As you can see, there are multiple steps in this kind of question. Alright, so we will need to write statements so that we know in each particular step, okay, what are we trying to find. Okay, so this one will take mole multiplied by mR. So 1.75 multiplied by 56. I should get 98.0 grams. Yeah. Okay, sorry, having a blocked nose. Alright, so once this is done, then I'll go on to question 12. Okay, let's look at the next part. So you are given 8.4 grams of magnesium carbonate. So now think about it. Okay, how do we actually find the mass of the magnesium oxide? Okay, so okay, maybe you pause for a while, think about it. So what's the first thing that we can find? You have to think is that you want to get the number of mole of your MgCO3. Okay, that can be done by dividing by mR. So this mass over mR. Okay, next thing, mole ratio. So this part is your mole ratio. Use mole ratio, which is I believe is 1:1. Okay, then from there you can multiply by the mR of MgO to get the mass of it. Okay, so let's begin by finding the number of mole of your magnesium carbonate by taking mass over mR. Mass is 8.4, mR is 24 plus 12 plus 3 times 16. Okay, so that will give you 0.1 mole. Then after that, we know the ratio of MgCO3 is to MgO. Okay, 1:1 ratio. Okay, so now what you can do is you can find the number of mole of your MgO. That is 0.1 mole. Then after that, you can find the mass of your MgO already. Okay, since you already reached here, take the mole multiply by the mR. Okay, then you should be able to get 4.00 grams. Alright, so any questions, you can feel free to stop me in class, when you see me. Okay, let's look at example 13. Okay, example 13, I think, needs you to write a chemical equation based on your zinc and sulfuric acid. Then you have a salt being formed and hydrogen gas was produced. Okay, actually nothing new. Back in N levels, you already know this reaction. It's an acid metal reaction. Okay, so then there will be a salt and hydrogen. Okay, so acid plus metal gives you salt plus hydrogen. Okay, or metal plus acid gives you hydrogen and salt, means the same thing. Right, then you get zinc sulfate. Okay, zinc is Zn2 plus, sulfate formula is SO4 2 minus, as well as hydrogen. Okay, so you are told this is 0.805 grams. Calculate the mass of zinc that they use. Okay, so same thing, you need to go to mole. Okay, maybe the other way around. So same thing, got to change this to mole by dividing by mR. Okay, then you can mole ratio over, which is 1:1. Then you multiply by the AR to get the mass. Okay, so for this, the number of mole of ZnSO4 will be the first thing I try to find. Right, so 0.805 over 65 plus 32 plus 4 times 16. Okay, so this is 0.005 moles. Okay, so then the next thing, okay, what you can do is mole ratio over to find the number of mole of zinc. This one is mole ratio, not mass ratio. The last thing I want you to do is take 0.805. Then assume this is also the number of mole of zinc is also 0.805. I mean the mass, sorry, not the mole. So this is also 0.05 moles. Right, and then so now I up to here, one last step, okay, to get the mass of zinc. So that will be mole multiplied by molar mass, 0.005 multiplied by 65. So 0.325 grams. Okay. Okay, so alright, got a couple more examples to go before I finish this particular part. Okay, so next thing we have zinc nitrate decomposes when heated strongly. So starting from this fella, zinc nitrate is 0.5 mole. You are asked to find the mass of this zinc oxide. Okay, so first thing you do is this. Okay, is to find how many moles of zinc oxide. Yeah. Okay, then after that multiply by the mR. Because this is already in mole, so slightly easier. Okay, then mole ratio is 2 zinc is to 2 ZnO. So basically the same number of mole. Alright, so first thing I do is find the number of mole of ZnO. 0.5 moles. Okay, then after that you can find the mass of your ZnO by taking mole multiplied by mR. So that will be 40.5 grams. Yeah. Okay, so the next thing okay, is you need to find the volume. Okay, so maybe I copy the equation down over here. It will be easier for me. Right. Okay, so you need to find the volume of this. So before finding a volume, okay, what we need is actually the mole. Then you multiply by 24 dm cubed. So we are told zinc nitrate is 0.5 mole. So then you mole ratio over, which is times 2, because it's 2:4. Okay, so first thing first, find the number of mole of your NO2. So 0.5 times 2, so it's 1.0 mole. Okay, then next thing, okay, you are good to find the volume of your NO2 by taking the number of mole multiplied by 24. So 1 times 24, get 24 dm cubed. Okay, so once okay, then we go to question 15. Okay, so 24 grams of sodium reacts completely with water to form sodium hydroxide and hydrogen. Okay, you can try to practice on your own first before you listen to this video. Alright, okay, so I have 24 grams of this. Okay, I'm asked in the first part to find the mass of the water. Okay, so you have to find the number of mole of sodium first, then mole ratio over, then multiply by the mR of water. So this part is divided by the AR, okay, relative atomic mass of sodium. Okay, so let's find the mass of find the number of mole of your Na. So you can do a mass over AR, 24 over 23, so 1.043. Okay, then after that the mole ratio is 2Na is to 2H2O. So the number of mole of H2O equals to 1.043. Then you can find the mass of water by taking a mole multiplied by mR. So 18.8 grams. Okay, so next thing you are asked to find the mass of your sodium hydroxide. Okay, you need the mass of this. You are told this is 24 gram. So you sort of have the number of moles area from the previous part. When you divide it by your AR, get the mole. Then you can get the number of moles of your sodium hydroxide, then multiply by mR. Okay, so first thing, the number of mole of your sodium hydroxide, 1.043, and then the mass of your NaOH, you take mole multiplied by mR. (23 plus 60 plus 1). Okay, so 41.7 grams. Right. Okay, so next thing, the volume of hydrogen. Okay, so now you are given this way. Okay, once again, let me copy down. Okay, so you are given this is 24 grams, which you can find the mole by dividing by the AR. Okay, so get the number of mole, then after that mole ratio over, then you can get the volume by multiplying by 24. Okay, so the number of mole of Na, take mass over AR, 24 over 23. You should find in the earlier part already lah, I believe. Yeah, 1.043. Okay, then after that, okay, the number of mole of your H2. Oh, wait, need to divide by 2. So you get 0.5215. Okay, then you can get the volume of your hydrogen by taking mole multiplied by 24. So 12.5 dm cube. Okay, so we are down to page 16 already. Any questions so far, please feel free to stop me. Okay, so next thing that we are going to look at is this one. Okay, so motor cars are often filled with airbags which rapidly inflates during an accident, protecting the driver as well as the passengers. Alright, so the bags are filled with nitrogen gas, which is produced from the decomposition of sodium azide into its elements. So now you are required to construct the equation. So sodium azide. So if you read the question, you have nitrogen gas and into its elements. So what you have is N2 plus Na. So 2, 3, 2. That's the balanced chemical equation. Okay, so you are told that in a car crash, the typical airbag is filled with 84 dm cube of nitrogen. So calculate the mass of sodium azide needed. So you want to find the mass of this fella. So very simple. Get the number of mole first, divided by 24 dm cube. Then after you get the number of mole of this, multiply by 2/3 because the ratio is 2 to 3. Then after that, multiply by the mR. Okay, so 3 steps. So the number of mole of your N2, take volume over 24. Volume is 84, then divided by 24. Okay, 3.5 moles. Okay, then you want to find the number of mole of NaN3. Take 3.5 multiplied by 2/3. Okay, so 2.3333. Okay, then you can find the mass of NaN3 already by doing a mole multiplied by mR. Okay, so the mole is from the previous step. And this is 23 plus 3 times 14. Okay, so that will give you 152 grams. Okay, now final example for this segment. Okay, so in the experiment, 2.5 grams of iron was reacted with excess hydrochloric acid. So the equation for the reaction is this. So wait. Okay, so you are told iron is 2.8 grams. Then you want to find the mass of this fella. So what you need to do is first thing, get the number of mole of iron by taking mass over AR. Should be very familiar with this formula since you did it in N level. Then mole ratio 1 to 1 multiplied by mR. Okay, so first thing first, find the number of mole of your Fe. So 2.8 divided by 56. 0.05 mole. Okay, so next thing, find the number of mole of FeCl2. So you take the mole multiply by mR. The mole should be the same. So this one is 1.20 dm cube. Okay, then for the next part, you want to find the volume of the hydrogen. Okay, so let me copy the equation so I got more space to write over here. Okay, you need to find the volume of this hydrogen gas. Yeah, given this is 2.8 grams. Alright, so first thing that you have to do is this. You have to get the number of mole of the Fe. Right, like what we did just now, which actually you already done. This one you know it. Then mole ratio over to the hydrogen. Then since this is a gas, mole 24, then gives you the volume. Okay, so we shall do that. So Fe is to H2 is 1:1. So the number of mole of your H2 should be the same, 0.05 mole. Same as this one. Yeah. Okay, so then next thing you can get the volume of your H2 already by taking mole multiplied by 24 dm cube. So this is 0.05 multiplied by 24. So you should get 1.20 dm cube. Yeah. Right. Okay, so I have covered the first segment of the mole ratio. Alright, so the next segment I'm going to touch on is volumetric analysis, which is in the next video.